Welcome to handout 13.4, page 2, problem number 9. So let's go ahead and read this problem. The lottery costs $2 to play. You must pick 5 digits in order from 0 to 9 and duplicates are allowed. If you win, the prize is $10,000. Calculate the expected value of the lottery. Determine whether the lottery is a fair game. Okay, so let's make sure we understand how we play the lottery. We go and hand them $2 and then we pick 5 digits. Okay, so they can be anywhere from 0 to 9, any of those numbers, and we can repeat them. So if our favorite number is 11222, we can use that. It's repeated digits are okay. Or you could have all the same digits, 11111, 5 times. Okay, so what does it mean to win? Well, for us to win this game, we would have to pick the correct 5 digits. So there's only one winner. Maybe the winning number is 1, 2, 3, 4, 5. If we got that, then we would win the $10,000. If we picked any other number, we would not get it. And in any other order, because notice it says order is important. So if we pick the correct numbers, but in the wrong order, we don't win. All right, so let's see what we can do. So notice here that we've been asked to find the expected value. So that means find that E. So if we look at our formula sheet again and look at E, here it is. Here's the formula for expected value. So we have to figure out the value times the probability. So let's take a look at what's going to happen. It's again the situation where we're either winning or losing. So let's talk about winning first. That's more fun. Okay, how are we going to win? Well, we have to pick the correct 5 digits in the right order. So we're just going to write outcome here. And we'll just write correct 5 digits. That's what it means. Correct 5 digits. That's what it means to win. Okay? And then let's talk about what it means to lose. Well, if we lose, we picked the incorrect 5 digits. We'll write in order here. Okay, it has to be in order. All right, so now we're going to go ahead and calculate how much we will win if we win. Well, we're told $10,000, but we paid $2 to play the game, so really how much did we win? $10,000 minus 2. So let's do that. $10,000 minus 2. What does that equal? That equals 9,998, and that's our X value. Okay? Then back here, what if we lose? Well, we're not going to win anything, so 0. But we paid $2 to play the game, so we really lose $2. So 0 minus 2, negative 2. So that's our X value. Okay, now we need to go ahead and find our P, our probability associated with each of these. Okay, so when we figure out our probability, we're going to say, how do we choose the correct 5 digits? So really what we're asking ourselves, okay, calculate probabilities down here. Let me move this over a little bit, make sure you can see all of that. Okay, calculate probabilities. Okay, so the correct 5 digits, we're really asking ourselves, how many ways are there to pick the correct 5 digits in order? Okay, well, when we pick the first digit, remember our techniques here. When we pick the first digit, how many different ways are there? Well, we can pick 0 all the way up to 9. So if we count that, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different ways. Okay, how about the second digit? Well, this is where we have to think. Remember, when we were counting, can we pick all of those digits again? Is repetition okay? Yes, we're allowed because it tells duplicates are allowed. So we have all 10 digits to pick from again. And so on, all the way through. So the third digit is the same thing. We have 10 choices. The fourth digit, we have 10 choices. And the fifth digit, we have 10 choices. Okay, you can get out your calculator, but you don't need it, because when you look at these, just ignore the zeros, and 1 times 1 times 1 5 times is just 1. And then count up the zeros. 1, 2, 3, 4, 5. So put 5 zeros. 1, 2, 3, 4, 5. Go back and put your comma in. There are 100,000 ways to choose these numbers if we're talking about in order with replacement. Okay, so then what is the probability going to be that we calculated the correct 5 digits? Well, the probability of the correct 5 digits is going to be the number of ways to pick correct 5 digits over the total number of ways. Oops, total number of ways. Okay, well, there's only one way to pick the correct number. There's just one correct number. Out of how many total? 100,000. All right, so that is our answer for the probability here. So we're going to say the probability is 1 over 100,000. Okay, let's think about the probability of picking it incorrectly. Well, if there's just one right answer, how many wrong answers are there? All the rest have to be wrong. So 100,000 minus 1, there has to be 99,999 wrong ways to do it. When we add these two together, we see that we get everything, total of 1. When we add 1 and 900, I keep wanting to say that wrong, 99,999 together, we get 100,000. So that's all of the possibilities. Okay, now we know if we're calculating E is going to equal x sub 1, p sub 1 plus x sub 2, p sub 2, because we have two possibilities. So we go on here and we say that we have 9998 times 1 over 100,000. Forgot to label that column. It's x times p here. And then negative 2 times 99,999 over 100,000. Okay, so now let's plug it in. We have 9998 times 1 over 100,000. And then we're adding to that negative 2 times 99,999 over 100,000. All right, time for our calculator now. All right, so what are we doing there? We're going to clear it out, and we're going to say 9998 times 1 divided by 100,000. Make sure you get the right number of zeros on there. Plus, and then in parentheses, be careful here, negative 2 again, close the parentheses, and then we have 99999 divided by 100, and then 3 more. Okay, close the parentheses, hit an equal. That's what we get, negative 1.9. Okay, so negative 1.9. Okay, now we have to think about what it is that we found. Well, we were being asked to find the expected value of the lottery. So how much do we expect to win when we play this game? Well, do we expect to win it all? It's a negative number. So that means that you lose. Okay, just like our problem up above was positive, since this was positive number, we can say expect to win. Expect to win. Okay, so but here with this one, since it's a negative here, we lose. We expect to lose. Okay, expect to lose. All right, so let's write it out. We expect to lose how much? This is in terms of money, so we're going to say $1.90, right? Got to put the 0 on there. We expect to lose $1.90. Is this game fair? No. The game is not fair since E is not 0. Okay, it has to be 0 for it to be fair. You shouldn't be expected to win or lose. When you think about it, the lottery, Vegas, everything is in it to make money. So, you know, you wouldn't expect that you're going to win any money. This was a problem obviously I fudged on the things. That's not going to be a game in Vegas if you expect to win 85 cents. The lottery is trying to raise money for schools or whatever it is. And so here you're expecting to lose money. Every time you play the game, lose $1.90. Okay, that's it for page 2. Go on to the video for page 3.